Okay, folks, so in a minute here we're going to look at solving this particular system of equations star, which is of 3 equations, 3 unknowns. It'll be a little more labor intensive than the last one. But before we do that, I want to run through these steps that I talked about in the previous video. So I've gone ahead and given you very detailed steps. You can read through these. I'm going to go ahead and these are the summary. What I put in bold is sort of the summary of the steps. So I would read through these, make sure these make sense for this procedure. This is for the Gauss. Again, this is the steps for the Gauss-Jordan Elimination. I'm not going to worry about calling that by its correct name. There's Gaussian elimination, which is very similar, and there's other ways of giving names to this procedure. But this is, our textbook calls this the Gauss-Jordan elimination. So the big thing is that initially you get a 1 in what we call a pivot position, and I'll explain that more in subsequent videos where you don't get where it's impossible to find a pivot where you would expect to find one. So you get a 1 in a pivot position, and you do so by dividing the pivot row by that coefficient of the current pivot position. Then the next main goal is to get zeros below and above the pivot position. If we're using Gauss-Jordan, we want above as well. And you do that by doing a linear combination. So I'm going to let you read through this. These steps should outline exactly what I'm doing here. Take a few minutes, but I'm just going to go ahead and again work this algorithm by way of an example. So let's go ahead and build the system of equations here put it into an augmented matrix. So we've got 2, minus 4, 10, 6, negative 1, 5, negative 8, 0, 2, negative 3, 11, 11. Now sometimes in introductory linear algebra books, they will show you swapping rows to begin with. And I'm going to ask you, or I'm going to encourage you not to do that. When I give you one of these, I want you to follow the algorithm as I've outlined it. And the only reason why you swap a row is if you're trying to get, if it's impossible to get a pivot in your current row. So you'll see what I mean in a later example. So I'm not going to swap any rows here. Even though this has a negative 1, you might think, oh, maybe I should swap these 2 rows. But I'm not going to. Instead, let's just go ahead and this is going to be our pivot position. So using that vocabulary, there's our current pivot position. It is possible to get a 1 there. Notice that this column doesn't have all zeros. That's what makes it a pivot column. So it's possible to get a 1 there. So let's go ahead and do that. We're going to do that by saying our new row 1. And if you look at those steps that I gave you, we said get a 1 by dividing your pivot row by the coefficient of the pivot position. Well, what's our coefficient? Our coefficient's 2. So we're going to divide by that. So we're going to say that our new row 1 is going to be 1/2 the old row 1. Okay. So let's go ahead and divide this first row by 2. That gives us 1, minus 2, 5, and 3. Double check me. 1, minus 2, 5, and 3 for that first row operation. And again, I don't like to get 1s in a pivot position and 0s below them or above them in the same step. I like to treat those 2 as 2 separate steps. So you might think, well, why don't you do a little bit more work here? I find it a little bit too difficult to manage. All right, so now we've got a 1 in this pivot position. We're looking at our steps. Now you want to obtain zeros in all entries below, and since we're doing Gauss-Jordan elimination, and above that current pivot position. To do so, we're going to multiply by the opposite sign of our working row. Okay, so let's go ahead and work on this row right here. Actually, let's work on this row right here so we actually have an example. This is our current working row. I'd like to get a 0 in this position. So to do that, I need to multiply my current pivot row. This is what I'm currently pivoting off of, this row right here. I'm going to multiply my current pivot row by the opposite sign of this coefficient right here, and then add the 2 together. So let's see here. I'm going to say that my new row 3 is equal to negative 2 current row 1 plus current row 3. Okay? So I'm multiplying this row by negative 2 and combining it to this row to give me a new row 3. So let's go ahead and do that. So let's see here. We'll multiply this one by negative 2. That gives me negative 2 added to 2. That gives me the 0. That's what I was hoping to get. Then we'll multiply this entry also by negative 2, so that gives us positive 4. Added to negative 3 gives us a 1. We'll multiply this 5 by negative 2, that gives us negative 10. Added to 11, that gives us 1. And then we've got our augmentation bar, and then we'll do 3 multiplied by negative 2, that's negative 6. Added to 11 is a positive 5. Okay. Now let's go ahead and also, we're going to go ahead and in the same step, we're going to get a 0 in this pivot position again, or excuse me, in this position here. So again, this is our pivot position, so this is our current pivot column, and we want to get a 0 below that pivot position. Okay. So let's see here. In this case, I'm just going to say that my new row 2 is equal to my pivot row plus the old row 2. I'm just going to simply add these two rows together. Or if you like, you could think of it as multiplying your pivot row by 1, which is the opposite sign of this coefficient. Okay, so I multiply 1 times 1, okay, add it to there, we get 0, that's what I was hoping for. Negative 2 added to 5 is 3. 5 added to negative 8 is negative 3. And 3 added to 0 is 3. And then I'll just go ahead and I'm not going to adjust my pivot row, so we just bring that on over. Okay, so now I'm in a position to explain what I mean by look for the next pivot position. This was our current pivot column. We got zeros above and below that the pivot position entry. So now my next potential location for a pivot column is right here. And as long as as long as there's at least one row below my former pivot row that has in this next potential column a non-zero entry, I will be able to make a pivot position there. So notice both this entry and this entry are non-zero, so I'll be able to get a 1 in this column, making it a pivot column. So this is going to be, since I've already got a non-zero entry here, this is going to be my new pivot position right here. So I need to get returning to the algorithm, we need to get a 1 in that pivot position, and we do so by dividing the pivot row by the coefficient of the pivot position. So here's my pivot row, and the current coefficient in the pivot position is 3, so I'm going to divide this row by 3. So we're going to say that the new row 2 is going to be 1/3 the old row 2. So here we go. Doing that, we would get 0, 1, minus 1, 1. And again, I don't feel comfortable now trying to get zeros above and below that pivot position. I'm just not that coordinated, so I'm just going to go ahead and recopy over those two rows. So I take a line, or I give a matrix to get a 1 in a pivot position, and then a separate matrix to get zeros above and below that pivot position. So this is my new pivot position. I've got the pivot 1 there, so this is my pivot row, and I now want to get a 0 in this position and a 0 in this position. Okay. So to do so, I'm going to go ahead and let's go ahead and multiply. Let's see here, for row 3 we're going to say that's equal to negative 1 row 2 added to the old row 3. So I'm going to multiply this row by negative 1 and then combine it with this one. Similarly, to get a 0 in this position, I'm going to say that my new row 1 is going to be 2 times my pivot row added to the old row 1. Notice that in this algorithm, I'm only ever multiplying my pivot row by a coefficient and then adding it to my previous row that I'm working on. Okay. So let's see here. For this third row right here, we're going to multiply all entries of our pivot row by negative 1 and combine them to our old row 3, and let's see what happens. So this gives us 0 times negative 1 is still 0, added to 0, that remains a 0. 1 times negative 1 is negative 1, added to 1, that gives us the 0 that we were after. That's the whole reason why we're doing this particular step. Then negative 1 times negative 1 is positive 1, added to 1 gives us a 2 in that position. And then negative 1 times 1 gives us negative 1 added to 5, which is a 4. Okay. For this upper position here, we're taking our pivot row, multiplying by 2, and adding it to this row. Notice that 1 won't change because that's a 0. 2 times 1 is 2, added to negative 2, that gives us the 0 that we were after. 2 times negative 1, so I'm doing 2 times negative 1, that's negative 2, added to 5, gives us a 3 in that position. And 2 times 1 is 2, added to 3, gives us a 5 in that position. And then since I'm not doing anything with my pivot row, I'll just copy that over. 1, negative 1, 1. So as far as the row reduction algorithm goes, we got a 1 in this first pivot position, 0s above and below it. Then a 1 in this potential pivot position with 0s above and below it. And now we want to get a 1 in this pivot position if it's possible. And it certainly is, because we've got a row, namely this third row, that has a non-zero entry in this potential pivot column. So it is possible to get a 1 here, and we'll do so by dividing this row by 2. So I'm going to say that my new row 3 is equal to 1/2 the old row 3, and that gives me 0, 0, 1, 2. And then we have, just copying over the previous rows, we'll have this. Notice that if all I were trying to do were just regular Gaussian elimination, or just to put this in REF form, I'm already done, because I've got 1s along the, potentially along the diagonal, and 0s below it. So I could go ahead and say, okay, we can see that z equals 2, and then solve very simple equations to find the remaining values. But I want to go ahead and put this into complete RREF form. Okay. So finally, this is what we were operating off of as our pivot position. We got a 1 in that pivot position, and now we want 0s above it. So let's see here. To do so, we're going to say that we want to simply add. To get a new row 2, we're simply going to add our old row 3, the pivot row, to the old row 2. And to get a 0 in this position here, we're going to take 3 times our pivot row. So this is the part that sometimes people miss. Notice I'm always multiplying my pivot row by the, oops, that should be a negative, by the opposite sign coefficient of what I'm trying to eliminate. So since I've got a 3 there, I'm going to multiply my pivot row by -3 and then add it to my current working row, row 1. Yeah. So let's see here. I'll just go ahead and copy across this row. Oops, I'll go ahead and copy across the bottom row, the pivot row, 0, 0, 1, 2. Now I'm multiplying, or I guess in this case I'm simply adding my row 3 and row 2 together, so I'm just adding up, so that gives us 0, 1, 0, and then 2, and that gives us 3. And finally, to get this row 3 here, we're going to take -3 times our pivot row and add up, so that gives us 1, 0. Then here we take -3 times 1, which is -3, added to 3, which gives us 0. Then we do -3 times 2, which gives us -6, added to 5, which gives us -1. Okay. Notice in this case that every single column ended up being a pivot column. That won't always be the case, and that's what we're going to explore in the next few examples. Okay. But at this point, this is a sequence of, and it seems like a lot of work, but this is a sequence of equivalent matrices, each of which corresponds to an equivalent system to this original system. And so now we can simply read our solution here. This says that z is equal to 2, reading this row, and that y is equal to 3, because this corresponds to the y column. So this equation is just 0x plus 1y plus 0z equals 3, and x is equal to -1. So our ordered triplet that is the solution is -1, 3, 2 is the solution. In this case, it was the only solution, so I'm going to call it the unique solution. So again, what I did here was follow this row reduction algorithm. It's sort of a pain to learn this. I'll give that to you. It takes a little while to learn the row reduction algorithm. But once you do, it's just sort of a sequence of steps you run through. The thing that we still need to explore is what happens when we can't make a certain column a pivot column. So we're going to look at that in our last couple of examples here. Okay. I do want to say in this video, I'll go ahead and say now a quick word on the algorithm. Okay. And my comment for that is always stick with this algorithm. Okay. I always intend when I make these, so if I put this on a test, I'm going to try to minimize the number of fractions you have to deal with in the matrix when you're doing your matrix row operations. I'm going to try to minimize the number of fractions. But I can't anticipate all the ways you might try to row reduce this, so you need to follow the algorithm. Notice in this case I set up this matrix so that there were no fractions. And on an exam I will make sure that if you have one of these just solving a system of equations, I'll set it up so that you don't have fractions, but you have to follow this algorithm. Okay. I think that's all I have to say for this. I know this was a long video, so thanks for sticking with it.